previous video, I explained how to create a precedence diagram starting from activities with their precedence information and duration. We added the durations of the activities to the activity nodes, but we did not use them yet. In this new video, I will use the duration information to calculate the start and finish time of all activities, the project duration, slack or float of the activities, and identify the critical path. In order to find all the information, we have to complete different successive steps. The first step is called the forward pass and starts at the beginning of the project with the activities that have no predecessor or at the start milestone, and we move from left to right through the network. Doing this, we will calculate the early start and early finish of each activity until we reach the end of the diagram. Once we are at the end, we know that the project duration and start counting back from right to left, and we call that the backward pass. Here we are going to calculate the latest time an activity should finish without changing the total duration of the project. This leads to the late start and late finish times of all activities. The next thing to do is to calculate the slack or float, which defines the flexibility each activity has to move or to be extended. The last item in this video is about identifying the critical path through the network. This is basically the series of activities that have the lowest slack. The official definition of the critical path will be given in the last slide. Let us now start with the calculation and with the forward pass, and let us have a quick look at the content of the slide before starting with the calculation. You can identify the precedence diagram we created during the first video, but we also have some other elements that are shown here. First, we have the node at the left of the PDM with the legend. You can see that on the top we have respectively the early start and early finish. Those will be calculating during the forward pass. At the bottom of the node you see the late start and the late finish, which will be calculated during the backward pass. And finally you see in green the slack, which we will calculate once the forward and the backward passes have been finished. Below we also find the formulas linking the early finish with the early start, and how we can calculate the early start of the successor when you know the early finish of the predecessor. But let us go back to the formula to calculate the early finish. Basically, we add the duration of the activity to the early start and subtract 1. This may look strange, but let us consider another example. Imagine you have a holiday of 3 days starting on March the 1st. When will your holiday finish? Well, when you look at the calendar, 3 days starting from March the 1st will end on March the 3rd. And when you consider this as an activity, the start will be March the 1st, plus the duration of 3 days, which give you March 4th. However, your 3 days end on March the 3rd, not on March the 4th. In order to have the correct end date, we have to calculate March 1st, plus 3 minus 1 equal March the 3rd. The second formula links the end time of the predecessor to the start time of the successor. Basically, we take the early finish of the activity and we add 1. Basically, it means that we will continue with the successor on the next working day. When our holiday finished on March the 3rd, basically it means that we will continue with the successor on the next working day. When our holiday finished on March the 3rd, the next thing we can do will start from March the 4th. In case you are a bit confused, just imagine that the project starts on March the 1st and we count from there. The early start of A then becomes equal to 1, and now we can calculate the early finish using the formula which gives us 1 plus 2 minus 1 is equal to 2. Using the reasoning as we described before, we can say that activity A starts at the beginning of the working day on March the 1st, takes 2 days, hence finishes end of the working day, which is March the 2nd. Based on the second formula, we can now calculate the start, or better early start, of activity C, which is the early finish of A plus 1, or in this case it is 3. And now we see the early start of C is equal to 3. The next step we have to do is calculate the early finish of C, which is given by the formula 3 plus 3 minus 1, which is equal to 5. And that is exactly what we find in the diagram. Now you can stop the video and try to do the exercise alone and restart the video when you have finished your calculations. But before continuing on your own, I have to warn you about something special and want you to think about it. Have a look at activity G or H, but let us consider G. What is special here? Well, G has two predecessors. And what does it mean when we want to find the early start of G? We can use the formula of the early start of the successor is equal to the early finish of the predecessor plus 1, but which predecessor do we have to select? Try to find the answer and discover if you were right or not. So, you decided to stop the video or not? Anyway, let us continue with a forward pass. Once we know the early start and early finish of A, we can also calculate the early start and finish of D. The early start of D is the same as for C, hence equal to 3. And now we can calculate the early finish of D, which will be equal to 4. Before calculating the early start and finish of G, we will return back to B. Since B is also at the project start and has no predecessors, the early start of B is also equal to 1. And the early finish of B is equal to 1 plus 4 minus 1, which is equal to 4. This brings the early start and early finish of E to be respectively 5 and 9. And we can do the same for F, which gives an early start at period 5 and an early finish at period 6. Now we can have a look at activity G and resolve the mystery of the two different activities and which early start to consider. G can only finish when both activities have been completed. This means that when D is completed, C is not completed yet and we have to wait until that happens. Basically, when we have more predecessors, we have to select the highest value of the early finish, in our case 5, and activity C. It means that the early start of activity G will be equal to 6. And we can calculate the early finish of G, which will be equal to 6 plus 3 minus 1, which is equal to 8. The same we can do for activity H. Here we consider the early finish of activity E, since it is the highest value, and we get the early start and early finish for H equal to respectively 10 and 12. The result is that we have two end dates, and of course the project duration will be equal to the highest number, in this case 12. The project duration is finally equal to 12, and we can get ready to start with the backward pass. Now it is time to start with the backward pass, and we have to remember that the project duration is 12 periods. At the left button you find the adjusted formulas for calculating the late finish and late start of the activities. We now start from the right and start with the late finish of the activity, and in order to find the late start we have to inverse the formula we used for the forward pass, which leads to the late start, which is equal to the late finish minus the duration plus 1. And we have the late start of a successor. We can find the late finish of the predecessor by using late finish of the predecessor, which is equal to the late start of the successor minus 1. The first thing to do is to find the late finish of G and H. And we have to remind here that the late finish is equal to the duration of the project, and we get that the late finish for both activities is equal to 12, or the project duration. A typical mistake that many people make is that they select the early finish of G as late finish, and that is wrong. Let us look back at what the meaning of late finish is. The late finish is the latest time or period an activity can finish without changing the project duration. This automatically means that G can finish the latest at period 12 without changing the project duration. In case you would make the mistake, there will be more than one path with the lowest slack. Hence, we could conclude that this would be the critical paths, but that would be directly in contradiction with the definition of the critical path, which is the longest path through the network. Once we know the latest finish of G and H, we can calculate their latest start by using the formula 12 minus 3 plus 1 is equal to 10, and this is the same for both activities. Now we have to calculate the late finish of the predecessors D and C, which gives us 10 minus 1 is equal to 9. Now you have again the option to stop the video and conduct the calculations on your own and compare them with my results, or you just continue. We can find the late start of C using the formula 9 minus 3 plus 1, which is equal to 7, and do the same for activity D, which gives us 9 minus 2 plus 1 is equal to 8. The next step is to continue with E, which has a late finish equal to 10 minus 1 equal to 9, and a late start equal to 9 minus 5 plus 1 equal to 5. For F, we find a late finish of 9 and a late start of 8. Now we have to find the times for activity A, and here we have a small problem. A has two successors and we have to decide which of the two to select. Remember, in the forward pass we had a similar problem and we selected the highest value, and let's have a look what should happen here. Imagine we select as late finish for A, the value of 8 minus 1 is equal to 7. When we calculate from 7 the start of C, we find 7 plus 1 is 8, and that is higher than the late start of activity C, hence would lead to a longer project duration, and that is unacceptable. It is clear that since we cannot take the highest value, we have to take the lowest values, which is 7, and the latest finish of A is then equal to 7 minus 1, which is equal to 6. The same we do with activity B, and we find respectively 4 and 1. This is the end of the backward pass, and now we can calculate the slack or float. The formula is on the top left, and the float or slack is equal to the difference between late start and early start, or late finish and early finish. For activity A, we find that the slack is 6 minus 2 is equal to 4, and we continue this for all the activities. For B, we find 0. For C, it is 4. For D, it is 5. For E, it is 0. For F, it is 3. For G, it is 4. And finally, for H, it is 0. Now we can continue with the identification of the critical path. The critical path is the path made of the activities B, E, and H, but why did we select this path? Well, as you noticed, all these activities have a slack equal to 0. But is this the correct way to select the critical path? Well, it is not, because the critical path is the longest path through the network, and the path BEH is 12, while other paths are shorter. In this particular case, the CP also has slack equal to 0, but in some special cases this may not be true. Be aware when you select a critical path, and always consider the definition as mentioned before. This was a long, and for some or maybe many, a complex session. Anyway, if you feel unsure, you can review the session or use some of our YouTube videos on our YouTube channel. I hope you learned a lot, and I'm looking forward to seeing you in the next session.